for new flavor in your ear. I'm kicking new flavor in your ear, like a brand new flavor in your ear. Here comes a brand new flavor in your ear.
Yes, it's always time for marketing analytics flavor in your ear. Hello, this is Eric Riney coming to you again from Webster University with another marketing analytics procedure. In this one, we're going to be discussing price optimization. So, what is price optimization? Simply, it's a way for us to identify the price point that maximizes expected outcomes. Now, those outcomes could be anything from profit to market share to revenue or some other metric that we anticipate can be estimated by price. And what we mean by price optimization is that the price is optimized such that it maximizes whatever that outcome is. So if we think about pricing and the way pricing is normally determined or traditionally determined, there are really three primary ways that we determine price. One is cost plus pricing. And cost plus pricing is simply where we have our offering, in this case, a hamburger, and it costs us $1.73 to make. And what we do is we say we're going to add $4 or some amount to that cost, and then that gives us our ultimate price. So $4 plus $1.73 gives us a price point of $5.73. This is a really simple way of coming up with a price point. It's used often along with the other procedures because of its simple technique to use it. And also because you can guarantee that if you are able to sell your offering, you're going to make a profit. It's guaranteed. It's built in. The second one is margin pricing. This is very similar to cost plus pricing. You take your cost, in this case $1.73 again, and we're going to add some markup, 60% in this case. And what we do is we say, okay, $1.73 times 60%, that gives us our markup points. We add that to $1.73, and in this case, we come up to a price point of $2.77. Again, relatively easy to do. You do see a lot of companies that use some type of marginal pricing as one of their primary metrics. Why? Well, it's easy to measure. It's easy to see if you should sell a product or not. If you can't meet that marginal price, or if it doesn't get to that marginal price, then you know you don't want to sell it. You move on to something else. The third traditional pricing determination is competitive parity. Now in this case, what we do is we have our hamburger. It costs $1.73. But instead of looking at our cost, basically what we do is we look to our competitors and we look to see if they have a product that's similar to ours, and we price ours relatively close to what they price theirs. So if competitors' prices are at $4, guess what? We price ours at $4. And again, very simple. This one is used often for people who are new into the market, especially if it's a market that's already mature. It's a way for you to not rock the boat as far as competitors. Again, as long as the price is above the cost, you're able to sell at that price, you should make a profit. Now, what is the problem with all three of these traditional pricing determinations? They're missing one key thing: the market value. This is the value that the market is willing to pay for your offering. What if they're willing to pay $15 for your hamburger because you use fresher ingredients? Maybe your beef is higher quality. Maybe your chef is better. Maybe it's just a better tasting burger. But you're selling it at the competitive parity point of $4. How much are you leaving on the table? $11. That's a lot of money per hamburger. And the same thing could be said about cost plus pricing as well as the markup. Again, while they can guarantee that you're profitable, it doesn't mean that you're optimizing the price and actually capturing the value that the market is placing on your offering. So what we want to make sure we're doing is that we are making a profit, and not only making a profit, but that we're maximizing that profit. We're trying to get as close to the point that the market is willing to pay in relationship to our product, but also looking at how that impacts demand. Ultimately, profit maximization or revenue maximization should be our focus and not just if we're profitable or not. One of the ways we can do this is by doing a demand estimation model. Simply what this means is that we want to be able to come up with an estimation, a function that we can use to predict demand based off of specific prices. So as we move prices around, we want to be able to forecast what demand will be. We do know that there is an inverse relationship between price and demand. That simply means that as price goes up, demand goes down, and vice versa. As price goes down, demand goes up. What we don't know is how much. If we move price a little bit, how much does that impact demand? For instance, if we have a relatively small or large increase in price, demand doesn't change very much if we're talking about gasoline. But if we're talking about vacations, you may see a much bigger impact on demand for changes in price. What we want to be able to do is use this information, make a determination of the impact price might have on our product offerings, and use that then to estimate what demand will be as we change price. This is simply known as a demand model or a demand equation. And the demand equation, it looks very familiar. It's simply a line equation. It's y equals slope, b or beta, times price, x, plus some intercept. So y is the demand. It is our outcome variable. It is what we're trying to estimate. B, or the slope, is simply the impact of price on demand. It is the measure of that relationship between price and demand. X is price, and then we have some intercept or starting point. And what we mean by that is that we anticipate that everybody's going to sell about this baseline number of products, but then as you move price up or down, you will impact that demand by some amount. One of the things that can impact our ability to anticipate the demand equation is what's called price elasticity. This again is another way to measure the relationship between price and demand. It is not the demand equation, but it's something that we can use to help us to find the demand equation. So what is price elasticity? Well, it's simply the percentage change in quantity demanded divided by the percentage change in price. I know that looks like a lot. It looks really complex, and I'm about to make it even more complex. So if we look at how we calculate price elasticity of demand, we see that we have in our numerator another fraction, and it's simply looking at the demand, the quantity that we get at a particular price point. So we're looking at quantity 1 and quantity 0. So at 0, we expect to sell this amount at P0, which is price 0. So at this price, we anticipate selling this amount. As we move to price 1, whether that's up or down, we expect to sell this demand, or we have sold this demand or this amount, this quantity. So that's what Q1 represents and Q0 represents. But let me break this down a little bit and help you really understand. So first, let's start with the quantity part of the price elasticity of demand. So looking at the numerator, the percentage change in quantity is simply one quantity and then a second quantity, right? So Q2 minus Q1 divided by Q1. Now, I do realize that in the previous slide, I had Q1 and Q0. It doesn't matter. It's simply two time periods, two price points that we're looking at how demand changes. All right, so let's look at an example. Let's say time one, Q1, we sell 100 items, 100 units of whatever our product is. Let's say it's the hamburgers. And at time two, we sell 110. Now this assumes that we have some price point that we've sold our hamburgers at time one, and then at time two, we see that demand has gone up. That means that price has gone down. All right, we'll look at the price side in a second, but let's just calculate the percentage change in quantity really quickly. Now that we have our two price points, we just plug and play. So we have quantity 2 or time 2, the demand at time 2, we sold 110 at that particular price point. Subtract that from time 1, which is 100, and then we divide that by 100. So if we calculate the numerator, 110 minus 100 is 10 divided by 100, ultimately gives us a percentage change in quantity of 0.10. Now, one of the things to also consider here is that we could have a lower price, or I'm sorry, a lower quantity than our quantity at time 1. In this case, quantity went up because our price went down. Again, I'll show you price in a little bit. But let's say that we raised our price such that quantity goes down. We could also do that calculation as well. In this case, we have where at time 2, instead of it being 110, it's 90. So it would be 90 at quantity 2 minus quantity 1, 100, divided by 100 gives us negative 10 over 100. That gives us negative 0.10. All right, it's still 0.10. It's a change of 0.10, but it's in a different direction. It's simply because our demand has gone down instead of up. All right, let's look at the price side now. Similar to the demand side, our equation is price 2 minus price 1 divided by price 1. And at price 1 or time 1 for price, we sold our hamburgers at $100. Maybe these weren't hamburgers. I doubt we're selling hamburgers at $100. So whatever this product is, we're selling it at $100. And we already know that our demand went up, and we see that, oh, our demand went up because our price went down to $75. So now we can do a calculation of percentage change of price. Simply again, plug and play. 75 minus 100 divided by 100 gives us minus 25 over 100. That gives us a negative 0.25. Now we can actually calculate price elasticity of demand. If you remember, percentage change in quantity was 0.10 and percentage change in price was negative 0.25. This gives us a price elasticity of demand of negative 0.40. Now, we normally wouldn't say negative 0.40 because we know price elasticity of demand is an inverse relationship. And so we would just disregard the negative and say price elasticity of demand is 0.40. What does this mean for us? Well, price elasticity of demand simply states that a change in demand would result for every 1% change in price. In this case, a 1% change in price would result in a 0.4% change in demand. As price goes down by 1% change, then we expect demand to go up by 0.4% and vice versa. Okay, now that we've done these and I've explained this to you, I'm actually going to go over into Excel and we're going to get into the analytical technique of creating a demand curve that we can use in order to do our analytical procedure of price optimization. So I've gone over to Excel and I've inputted the demand and the price that we started off with in my example over in the PowerPoint slides. We have at price 1, $100. We had a demand of 100 units. Then at price point 2, it was $75. And we have a demand of 110 units sold at $75. All right. So again, ultimately what we want to do is come up with a demand equation that we can use in order to solve or optimize our price in order to maximize our profit. So we want to come up with profit. The way we come up with profit is that we have to have certain variables. We have to have a price variable. We also have to have a cost variable. And then we also have to have demand. And at that point, we can determine what price is. So I'm just going to type in here unit cost and unit price. And we want a demand at that particular price. And then we can anticipate. Okay, what I'll do is, just to simplify this, let's come up with unit profit. All right, and then demand, and then we can come up with the total profit. All right, and let's just add in, just for the sake of making this look a little bit better. Okay, so one of the things that we know is profit, unit profit is price minus cost. So I'm just going to add that in right here. Equals price minus cost. All right, it's 0 right now. That's fine. Just to have a number in here, I'm just going to start off with this arbitrary number of $1 in here. And let's just format all of these because all of these are going to be in units of dollars, not demand though. Okay. And so it's total profit. Now, total profit is going to be demand, whatever our demand is, times our unit profit. So however many of these units we sell at this profit, that gives us our total profit. All right, so what we want to do is we want to figure out what the demand is and then figure out what, if we change our price, what our demand will be, how that will impact our profit, and then ultimately our overall profit. And let's just assume whatever this product is, it cost us, let's say $30 to make. All right, that way we at least have we have all our variables. So your costs will be given. You should be able to calculate your costs or know what your costs are for the unit. And then ultimately you need to sell this at some particular price above. Right now at price 1 and price 2, we are selling those above the cost. So if we were to put $100 in here, then we know that our unit profit is $70. Okay. Now, how do we come up with this demand estimation, this line equation? Well, since we have two price points, what we can do is we can estimate a line equation using a scatter plot. All right, so one of the wonderful features in Excel is that you can do a scatter plot. I'm just going to highlight what I want to do as a scatter plot, and just click on here. And now we have our demand, and this is whatever the product is, this is demand. So we see here that at $75, we have demand of 110, and at $100 we have demand of 100. Now we want to get an estimation here. So if you add a trend line, all right, all I did, let's go back really quickly. All I did was just did a right mouse click on the dots, and it pulled up this little pull down menu, and I went to actually insert trend line would have been what I would have done originally. It pulls up this and it allows you to choose. Now in this case we want a linear. Some of the things we want to add to this is the equation. Look at that there. We can add an equation, and we can actually add an r squared. All right, we can close this, and there you go. This right here is our line equation that runs between these 2 points. All right, this is the estimation of the relationship between these 2 points. We have our slope, we have our x, and we have our intercept of y. This is what we're going to actually put over here. All right, so I'm going to type this in. We're going to say equals negative 0.4 times, now x is going to be whatever our price is. We don't want to use these prices up here. These prices were just arbitrary prices that we were selling at some particular time, but we want to be able to anticipate a price. So we're going to use this price down here. And now as I change this price, it will change demand down here. So we have negative 0.4 times our price plus 140 as our intercept. If I hit enter, now if I sell these at $1, then my demand will be, and this should not be dollars units, it should just be units. And since we don't sell partial units, I'm just going to round this. All right, so 140 units at $1 would be anticipated to be sold. All right. Now, for some reason, my unit price is not working right. I don't think I put this in here right. Let's see what I did. Okay, minus the cost is what I want. All right, so now we see that because we're selling this for $1 and it costs us $30 to actually make whatever this product is, we're losing $29 on every product that we sell. It doesn't matter what our demand is, because we're losing, we're going to be negative in our profit. All right. So if I were to just put, I'm just going to change this price to $100. What I should see is the demand should go to $100 too, because remember, I use this to anticipate this. And what this R squared means is that this is a perfect representation of this. So if I were to put $100 in here, this demand should change to $100. It does. As I said before, price at $100 minus $30 gives us profit of $70 times 100, which is the demand at $100 price point, gives us a total profit of $7,000. All right, now we still don't know what maximizes this profit. If I were to change this to $500, certainly my unit profit would go up, but we would know that demand would go down. Would we sell any of this product at $500? Who knows? Maybe we would, maybe we wouldn't. All right. And one of the things that is so great about doing this price optimization is that you do have some people who will simply say, if you want to be more profitable, just raise your price. Well, let's try that. Let's say we just want to raise our price to $125. All right. Well, we do see that profitability went up. We still have demand, which went down, and we're more profitable. So maybe we should sell this at $125. What if we went up to $300? Wow. Even at $300, we're still profitable, but guess what? Our profit went down. When we were around $125, we were making over $8,000. Now we're more profitable per unit, but because we're selling less units, we're less profitable. So what we want to try to figure out is, where is that sweet spot in terms of this price point? Where is that optimal price point that helps us to maximize profitability? So we can sit here all day long and fiddle around with the price, or we could allow Excel with its analytical tool to do it for us. And what is that analytical tool? It's called Solver. And all an analytical tool does is it goes through multiple calculations of whatever we're looking at and does those calculations for us so we don't have to do them. So because it's a computer, it can go through lots and lots of calculations a lot faster than we can. All right, so we'll go in here. It's under data up here in the tab window, and you'll see over here that we have underneath Analyse Solver. And if you don't have this, it's very easy. It's one of the add-ins that's available in Excel. Just go over to File and Options, and you pull this up, go to Add-ins, and you'll see that you have a Solver add-in right here. And so you can add it. You may have to close it and reopen it, but you'll see Solver on your as one of your options under Analyze. Okay, so we're going to go in here. Okay, we're going to go in here and really quickly let's get rid of some of this stuff because I've been using this before, and oh, okay, so it's not going to let me until I do this. All right, so what is it that we're trying to do? What is our objective in this particular procedure? We're trying to maximize profit. So that's going to be our set objective. So I'm going to highlight this cell, put it in here. And again, we want to maximize profit. In some cases, we might want to minimize our outcome variable, but in this case, we want to maximize. Okay. How do we want to have Solver figure out this maximum profit? Well, we want to change price. We want price to go up or down, figure out what it is that we should sell our product at. Okay. We could set some constraints, but right now I'm just going to delete the constraints. In some cases, you might want to set a constraint for your price. Maybe you don't want your price to go above a certain level or below a certain level, even if that does optimize the price. In this case, we're just going to let it do its thing. We also want to make sure that we have non-negatives. We don't want our variable, our price point, to be negative. Solver doesn't know what you're solving for, so it's going to find the point, and if that's a negative point, that's what it's going to give you. All right, but we don't want a negative point. Even though we're using a linear equation, what we're doing is a nonlinear type of method, so that's what we're going to use here. All right, that's really all we need in this simple analytical procedure using Solver. And if we hit solve, All right, it says that Solver has found an answer. There is a result. So Solver has converged to a current solution. There are some times where you might do something where Solver doesn't converge on a solution, and you might have to go back and see what you need to change. But in this case, we do have a solution, and we're just going to hit OK. Let me expand this a little bit. So what Solver has come up with is that at $190, we have a demand of 64. We have a unit profitability of 160. You multiply those together, and we maximize our profit at $10,240. Okay, so let's really, 10,000, let me just put that over here real quick. $10,240. All right, so if we were to go up to 191, we see that even though our unit profit went up, our total profit went down to 2, not by much, but it went down. It went down to 10. Why is this not working? It went down, if you can compare these two, it went down to $10,239. All right. If we were to go to 189, just a dollar below, and again, for some reason my keyboard is no longer working, but we would also see that the total profit, even though our demand might go up, the total profit would actually go down. So 190 is our ultimate price point. All right, so that's the simple way to optimize price. Now, there may be some cases where we might have some constraints. For instance, let's say that this is maybe a weekly demand that we're looking at. So maybe this was per week, how much we sold. And so we now have a demand of 64 per week. But maybe we can only sell 60 per week. So we could go in Solver and put a constraint in terms of demand and say, hey, we can have demand over 60, and it will recalculate the price point in terms of that constraint. All right. There may be other times where maybe we have a case where, for instance, up here, we see that, we have a demand of 100 and 110. And maybe in these instances, we have this demand because we have some type of arrangement, and, we get pallets that we have to sell in the range of 100. Then you could put that constraint in down here and see what your optimal price should be as well. But one of the things that just from this, you can see that we were really underselling our product at $100. And maybe this is done because that was the competitive parity price point. Or maybe it was done because that's the point that we did our markup, and this is the point we came up to. Okay, maybe at this second price point, somebody told us, man, if you lower your price, then you'll be able to raise demand and maybe you'll be more profitable. Or if we switch these around, somebody could have said, if you raise your price from $75 to $100, you'll be more profitable. That's $25 difference. And I know there are a number of people who will buy your product at $100. Well, yeah, that's true. And we know that if we were to put $100 in here, what the demand will be. Let's see so if we put $100 in here, the demand will be 100, and that gives us $7,000. So we're leaving over $3,000 on the table selling at this price point. So that gives you an idea of how to use price optimization. Now what we're going to look at is how we can actually calculate elasticity of demand. All right, so I'm going to minimize this right quick. And we're just going to calculate elasticity of demand. And it's just, it's something good for you to have. So we could do it by simply looking at, we'll say percentage change in price, or let's say quantity, and then percentage change in demand, price. All right, and here we have equals percentage change in quantity is the demand. So we know this is price 1 minus price 2, and then we divide all of that by price 1, and you see here it's 0.10%. We can do the same thing for price equals price 2 minus price 1 divided by price 1, and we have negative 0.25. And then our elasticity, sorry about that, our elasticity of demand, or let's just put price elasticity of demand, will be our quantity demanded by, and this should not be a dollar amount, so it's 0.4. So there you have it. Okay, so the next thing I'm going to do is show you how to calculate demand 2 if you are given a price elasticity of demand. In some cases, we may not have this information readily available. I mean, if you are able to do some type of experiment where you might be able to sell products at one price and then at a second price and come up with demand points, then we can do this line equation of estimation of demand and figure this out. But there are a lot of industries where price elasticity of demand has been calculated. So you can go find a price elasticity of demand for an industry, for particular products, and depending on the industry, you might be able to get down to certain types of products. Now, one of the things that you should be aware of is that price elasticity of demand for the industry or something like that is an aggregate, and it's looking at all the products. It's not necessarily looking at one particular product. And so the price elasticity of demand for your product might be very different than the price elasticity of demand for your competitors' products. I mean, if you have a stronger brand, if you have a stronger product, then your demand may not be impacted as much as you change your price as someone else. So you just need to be careful with that and adjust those industry metric standards of price elasticity of demand as you see fit. If you think you have a much stronger product, a much stronger brand, then you might want to reduce that price elasticity of demand such that there's less impact on price of on demand. But vice versa, if you feel like, well, your product is not as strong, your offering is not as strong, it's not seen as valuable, then you might want to increase the price elasticity of demand so that it has more of an impact than maybe the industry standard. All right, so I'm just going to copy this information down below really quickly. Actually, let's copy this whole thing down here. All right, So in this case, we don't necessarily know what our price, I'm sorry, we're given a price elasticity, and let's say 1.67 is our price elasticity. And remember, this is a negative price elasticity of demand. We do know that is the case. All right, so what we want to do is we want to be able to calculate price elasticity of demand as we change our price. And remember, this price elasticity of demand is in relationship to 1% change in price. So here I'm going to calculate 1% change in price. This is easy to do. A 1% change in price is just a change of $1. So we either go up $1 or down $1. But I'm going to show you how to actually put the formula in here. So we would do this price point times 0.01. And then we would either add or subtract that to the price. Now in this case, let's say we're going to go up by 1% point. So we have our price point A plus that 1% change. So we're going up by $1. All right. We do know that as we go up in price, demand should go down. Now, how do we calculate? And let me move this over a little bit. Just to show you. All right, so let me give you the equation for demand 2. So demand 2 is going to equal 1 minus the price elasticity of demand divided by 100. And then all of that will be multiplied times demand 1. Uh-oh, sorry about that. It thinks it's an equation, and it's not an equation. Let's put that in there. Okay. So let's put this formula in here and see if it works for us. Equals, open 1 minus this divided by 100. Close that off, times this price point, times, let's do that again, times, I don't know why this is doing that. All right. So basically, this is saying now, if we have a price elasticity of demand of 1.67, as we increase this by $1, our demand is going to be 98.33. All right. If we were to decrease this by 1% point, I'm just changing this to a negative, we go down by $1 to 99, then what we would do here is add this. So it's just the inverse, and we go up, you see here 1.67. All right. So that's the way that you would calculate demand 2 based off of the price elasticity of demand as we change by 1% point. All right. And we can test to see if this is working right. So if we put in this 0.04, oh, sorry about that. My laptop is doing crazy things. Okay. Well, we would really have to change this also to 99 to see if this were to work right. So, all right. Now, what we have in here right now is the demand equation using this up here, which was calculated using these price points. But now we actually have new price points. We have a new demand curve. All right. Before, what I did is that I actually did a demand line, used that to estimate what the demand curve was. I got the slope, I got the intercept, which I put in here. I'm going to show you a different way that we can actually calculate that. I'm going to put slope here and intercept. And we can calculate using an Excel equation called slope. Equals slope. We open the parentheses and it says, what are the known y's? Remember, our y is the demand. All right, so here our known y's are this 100 and this 101.67. And then, we put a comma. What are our known x's? Well, our known x's are the price and at time 1 and price at time 2. We close the parentheses and we have a slope of 1.67. All right, what is our intercept? Our intercept is equals intercept. Again, what are our known y's? The demand is our known y's. What are our known x's? These are our known x's. All right, we put that in and we see our intercept is 267. So this is what we will put in our demand equation down here. I am just going to insert these into my demand equation. All right, so my intercept is this right here. And I'm going to take this negative out too, because in my slope, it has the negative sign in there, and replace that there. All right. So again, we see at $100, demand is $100. If I change the price to $99, remember this is rounded, so it's 102 units, so it seems to be working correctly. All right. So now I can again go into Solver, and now I'm going to change this to this profit down here, maximize that, change what price. I'm going to change this price up here now instead of the other one. And let me add a constraint just so you can see it. So you go into add, and let's say we don't want demand to be under, so demand cannot be less than, demand should be greater than or equal to, and let's say 40 units. We have to sell at least 40 units for whatever reason. We hit OK, and we can see that's in there now. Okay. Many cases with demand, it's usually the most, so you have to sell less than, because maybe you have capacity issues and you just can't go over that amount. All right, so I'm going to hit solve, and very quickly it converts onto a solution, and now it says, hey, you need to sell at 94.94. You'll have a profit of 64.64. You'll sell 108 units, and you'll have a profitability of $7,403. And that's how we would, again, calculate profit maximization by optimizing our price point once we have calculated our estimate of demand, or once we've come up with a demand estimate model using our price elasticity of demand in this case. So there you have it. Okay. So I'm going to end this right here. In my next video, what I'll do is I'm going to extend this even further and look at complementary products and how we would optimize price when we have more than one product that depends on sales. Now that we've used price optimization in order to find the maximum price for one product, we can extend this to multiple products. Oftentimes this is done with complementary products. Complementary products are products that demand of one product can impact the demand of another product. Sometimes this can be a total dependency of one product on another product. For instance, sales of popcorn in a movie theater may be totally dependent on sales of movie tickets. A percentage of those movie ticket sales would result in popcorn sales. In other cases, we might have complementary products that don't necessarily rely solely on the first product, but a portion of the demand is certainly dependent on the first product. For instance, a hotel restaurant may derive some of its customers from hotel guests. Doesn't mean all the hotel guests are going to eat there, and it doesn't mean that all of the customers at the restaurant are hotel guests. So what we want to be able to do is to figure out how we can optimize our price for both products or both offerings and maximize profit at the same time. So I'm just going to copy, and I've already done it, copy this over to another worksheet in my workbook. And you see here that everything remains the same. We have our identified price point of $190, and that created a demand of 64 and gave us an overall price of $10,240. Okay, so let's assume that we have this complementary offering that we have. This offering cost us $10. And right now we don't know what the price is. We're going to come up with a price for it. So I have our profit, unit profit calculation in here as well. It's just going to be the price minus whatever the cost is. So at this point we're losing $9 because we have a price of $1 in there. Now we have to figure out the demand for this complementary product. In some situations, what we might do is simply say that the complementary offering is going to be a percentage of whatever it is that we're creating in terms of a demand for our first one. So let's say this is maybe a hotel stay or something like that for $100, $75, $190. And at the restaurant, we expect that maybe 30% will stay at the or eat at the restaurant. So this is pretty simple. And in this situation right now, we're not looking at price elasticity or creating a demand curve for this second offering. Right now, it is strictly a percent. So no matter what this price changes to, the demand is going to change up here, and then whatever this demand is, 30% of this demand will translate into demand for our second offering. So again, it's very simple. We just say equals 30% times our demand of our first offering. Okay, so 30% right now of 64 gives us 19 customers if we're looking at restaurant, and then we can calculate our profit. Now the other thing we need to add in, and I've already done it here, is a total profit. This total profit is just adding up our profit from our first offering and our product profit from our second offering. And that gives us this total overall profit. Right now, because we're losing $172, we're actually reducing this $10,240, and that's the result down here that you get. So now we can plug this into our solver and do the analysis and see what we come up with. All right, so I'm going to go in here to solver, And let's just take all these things out really quickly and start with a clean slate here. All right. So the first thing we're going to do is, at this point, we still want to maximize our profit, but instead of maximizing the profit for just one offering, we want to maximize the profit for both offerings, or in this case, the total profit. So I'm going to highlight this and insert it into my objective. Again, we're maximizing that. All right, now we have, for this occasion, two price points that we want to change. We have our price point for our first offering, which is this price point here. And I'm going to hold down my control key because I'm doing multiple points that I'm going to be changing in the variable cells. Our second price point is going to be offering 2, this complementary product. So I hold down the control key and enter, and now I have both those price points in there. At this point, I'm not going to add anything else, and I'm just going to hit solve. All right, so it says it did converge, and let's see what the solution says. All righty. So if we look at this at this point, for offering 1, wow, it says that we should sell offering 1 at 64 cents. We're actually losing over $29 for that. And as a result, we have a negative profit of $4,103. Now, why is this? Why did it do this? Well, if you go down here to the complementary product, you can see where the price for our complementary product is just outrageously high. Maybe, maybe not. I'm saying it's outrageously high, but we don't know. So it's setting the price for our complementary product at $1,273. And you see what the profit is for that. And if we get 30% of this 140, that's 42 people, and we see a whopping almost $53,000 in profit from that, resulting in over $48,000. So it's 52, almost 53,000 minus this 4,000 gives us this $48,867. All right. Now this looks like something that seems rather ridiculous. What on earth would we ever do with this? So let me explain why Solver came up with this solution. First of all, if we don't set any kind of constraints on this price, then it's going to go as high as it wants to in terms of this complementary price. In this situation, we see that it went all the way up to $12.73. And because of that, what it wants to do is to increase this demand as much as possible to sell as many of these complementary products in order to get this profit. It's going to forego profit up here because it realizes that it's going to create or obtain a much larger amount of profit down here than up here. So what it wants to do is to try to figure out how can we increase this demand of our complementary product. Well, this complementary product is as a result of our first product. So the more we can increase this first product, the demand for this first product, the more we'll get in our complementary product. So what does it do? It drops the price down to as much as possible in order to increase the demand up here. All right. Now, is there any situation where this might possibly happen? Well, yes, there really is. If you think about, for instance, cellular phone companies, the service like Verizon might end up selling the cell phone for almost nothing. You don't really see this as much anymore, but there used to be a day and time where you could get a cell phone for free. Why? Because they knew they could make the money off of the service itself. So they would give you the cell phone for virtually nothing, knowing that people would come in, and then you would have to sign up for maybe a 2-year agreement. And if you look at this might be for 1 year, $12.73, and if you do that for 2 years, we're looking at $2,400. I mean, really, $100 a month for a year, it's not too bad in terms of a service. So you could see how something like this might actually be the case, and we could have a result like this. But if we're doing something like, for instance, movie sales, or we're doing maybe a game console where we can't sell these complimentary games for $1,273, and we do really have some constraints on the price for the second product, well, then we're going to have to add those constraints in. All right, so let's assume in this case that we're actually doing game consoles, and the most we could possibly sell our games for would be $75. I haven't bought any games in a while. My son's older, he can buy his own games now, so I don't really know if this is realistic in terms of a price, but we'll just say $75. So I'm going to go back into my solver, and I'm going to add a constraint. And my constraint is going to be for this offering to complementary product, the price has to be either less than or equal to $75. And I'm going to hit OK. I'm going to leave everything else as is, and let's solve and see what happens. Oh, that was really quickly. Let's hit OK. And now we can see that, all right, we have something that may look a little bit more realistic. Previously, I think our offering was $190. It's now $182, which gives us a demand of 68. That demand of 68 is transferred down here is 30%. And then we can also see that we're going to sell this for $75, which makes total sense. I mean, previously we were selling this product for $1,200. We're going to sell this for as much as possible because we don't have any constraints in terms of price elasticity here. So we can see here that by selling these 20 for $75, we're going to make an extra $1,300 on top of this $10,000 that we made on our first offering, and that gives us a total profit of $11,526. So this is how we would do complementary pricing using price optimization analysis without any kind of elasticity of demand for the second product. All right, so let's take this a step further and let's look at if we have elasticity of demand for the second product. So over here, I've actually copied all of this over to a second worksheet, and right now it has everything that was calculated for our original complementary pricing, price optimization, the $75 for the offering, the complimentary offering, the $180.25 for our first offering. All right, now let's assume that this 30% that we said would be the complementary demand that would be derived from our first product is if we have a price of $50 for our second offering. However, we do have an elasticity of demand for this second offering. And let's say this elasticity of demand is 1.50. All right. And if you remember, this simply means that as price increases or decreases by 1%, then our demand will increase or decrease, the inverse relationship, by 1.5%. Okay, so if you remember correctly, we can use this then to calculate this second demand. Our $50, we're going to say we're going to increase by 1% because this is a increase of 1% in price. So if we're at $50, and that's what we've established is our 30% at $50, we get a derived demand of 30%. If we increase that by 1%, that's just 50 cents over this $50. That gives us $50.50 for this time 2. Now we can calculate what our demand will be at time 2. All right. So if you remember in the last section, I showed you how to make this calculation. In this case, we are increasing our price. That means our demand has to go down. So we'll use this second equation here. So what we're going to do is say equals, open paren, 1 minus our elasticity of demand score divided by 100, close the paren, and then divide that by our time 2. Oh, I'm sorry, that should not be divided by time 2. That should be multiplied times 2 instead. Let's go and change these. This should be multiplied. This should be multiplied. Okay, sorry about that. Okay, so we see now that as we raise price by 1% from $50 to $50.50, our demand drops from 30% down to 29.55%. All right, so now at this point, we could do a plot and insert a line and figure out what our intercept and our slope is, but we know we have a shortcut to this. We can actually just use our formula, intercept, and we know that our Y is our demand. In this case, it's percent. It's not actual number, but a percent of a demand. It's percent of the first offering. And then we're going to hit comma and then put in our price points for time 1 and time 2. And we'll do the same thing for slope. All right, and then our price points. And we can see that our intercept is 0.75 and our slope is negative 0.009. Okay, so now that we've done our intercept and our slope, what we're going to do is use this to calculate our demand. Now, one of the things that we have to do, you have to remember that right now, this intercept and this slope are going to calculate a percent for us. It's not going to give us the actual demand. It's going to give us a percent of the demand. So I'm actually going to insert here and add demand percent, because this is going to be percent of demand that is derived from the first product. All right, and we're going to say this is going to be the same demand curve type of formula. And if you remember, that demand curve formula is equals, so y equals our slope times x, which is price, plus the intercept. All right, so equals our slope times our price. Right now there's $75 in there, and that's just what we already had calculated previously, plus our intercept. And there you have it. All right, now this is not a dollar, this is actually a percent. All right, so if I were to put 50 in here, we should get 30% down here. That's just one of the ways that you can actually check to see if this calculation is working correctly. So 50, and it is 30%. So it looks like this is working correctly. All right, now what we have to do is actually multiply this demand percent times our demand up here in order to get our demand down here. So equals whatever we derived as far as our demand percent using our demand curve based off of our particular price point times our demand of our first offering. And right now it's still $20 because we have 30 in there. All right, but if we were to change this to $75, we can see now that our demand changes to 7% and our derived demand is 5 customers. And we can see what our profitability is. So now that we have this, nothing else changes. We still have our total profit, which is based off of the profit of each of our offerings. We can go back into our solver and we can figure out what our price is going to be. That optimizes, that maximizes our profit. All right, so we are going to again look at the total profit, so the profit of both of our offerings. I'm going to delete this out just to make sure it's in here correctly, and we want the price of our first one and the price of our second one in here. All right, and I hit OK and it converged, and we could see now that we went from $180 to $184 almost, demand of 66, and our price now for our second offering is $46.67, which created a demand of 33%, and that's a derived demand of 22 customers at a profit of $803, almost $804, and that gives us an overall total profit of $11,000. So there you have price optimization. And one of the things that you should always do when reporting results is to indicate what you did and what your results were. So in this particular one, we might say something like a price optimization was conducted for complementary products with an offering and a secondary offering, looking at elasticity of demand of both offerings. An optimal price point of $183.95 was calculated or determined for offering 1 at a profit of $153.95 per unit, a demand of 66 individuals, and a total profit of $10,225. Give the same one for the second one, and then the total profit, or for a total profit of $11,029. So you can say something like that. You might want to give some limitations. One of the limitations might be the age of your data. I don't know, how old this data is, or this elasticity of demand for this complementary product. Was this a industry elasticity of demand that you used here? If so, then there might be some limitations with using that one. So there are things that you would add to the report. But there you have complementary demand. All right. The next thing we're going to do is look at actually having more than 2 time periods to look at price and demand and see how that might impact our calculation of intercept and slope, and then ultimately our elasticity of demand. Okay, so the last thing we're going to look at in terms of price optimization is calculating our demand curve if we have more than two price points and demand points. So if we have multiple, three or more price and demand points, then it gives us more precise information. If you remember going way back, we have a price at time one, a demand at time one, a price at time two, and a demand at time two. And we use that to calculate our demand curve by calculating the intercept and the slope. And in our first example, what we did was that we actually used a scatter plot, added a trend line, and then did our estimation based off of those points. And our R squared is 1. The reason this is 1 is because we only have 2 points to define this line. And if you only have 2 points, then your line is going to be completely defined. All right, but if by chance you have a situation where you can have more than 2 points, then it may add precision in terms of your ability to estimate. 2 points, maybe these are accurate points, but maybe they're not accurate points. So I've created a third worksheet where I'm actually looking at multiple time periods for a price and demand. All right, and let's say we have these different price points, $1.90, $2, and $2.20, and we have all of these different demands that we could possibly have for these different time periods. All right, so I have a plot already over here, and I already have a calculation of the intercept and slope. But I'm going to delete this because I want to show you how we can actually use this. All right, so let's just do this first one to begin with. And I'm just going to copy these over here and put them in. So we have 1,300 at $1.90, 1,000 demand at $2, and 500 at $2.20. We see that our estimate of demand, or our demand curve, gives us the intercept and the slope of these two numbers, and our R squared is not 1, but it's pretty darn close to 1. And the reason for that is because our points are relatively close to the line. So this line does an excellent job of explaining these points here. All right, if I wanted to actually use Excel and the formula, the intercept formula, we could still do that with more than 2 time periods. So intercept, open brackets, and we know demand is our Y, so we're going to add all of these Y's in, comma, and then all of our prices for the X in close parentheses. And we see that this intercept of 6,307 is reflected in what we got over here in our scatter plot demand curve. And we're going to do the same thing for slope. And our demands at our 3 time points, and then our price at our 3 time points, and we should get something that is reflective of what we got up here, and we do. Okay, so again, these points seem to do this line seems to do a really good job of explaining these points. So let's take a look at this second example, and in this case, I'm just going to copy these over, and we see that, okay, now we have different demands at these same time periods, and you can see that our R squared has gone down to 0.93. The reason for this is because our points are not as close to the line as they were in the previous example, and certainly were not directly on the line as was the case when we only had 2 points. All right, but this still does a pretty good job of explaining our data. And as long as our R squared is zero point 0.9 or above, we can say that we can estimate with a good level of confidence something close to what would have actually occurred. All right. Um, so one of the things here is that my demand over here is the it's this intercept and this slope that's already here. I have that demand curve already over here, so it's this exact y equals negative 2,685.7 times the price, which is $1.90, plus this 6,441.3. But you see that our demand up here, our actual demand was 1,423, and at $1.90, our demand is at 1,338. So it's not quite what we actually um, had in time one at $1.90. Our estimate is a little bit off, which is indicated here again by this R squared, that our explanatory power of this line is not quite as robust as when we had this first one in. I'm going to add this first one back in really quickly. And now you can see that at $1.90, our demand curve changed because we have these different plots for our demand. Our R squared is a lot closer to something that actually occurred in terms of this line explaining the points. And we can see that at $1.90, we actually had demand of 1,300, and we're pretty darn close to that in terms of our estimate. And if we were to put $2 in here, we would see that we're going to be pretty close to this estimate. All right, but as our R squared moves further down from 1 or further away from 1, so as it's reduced, we're going to see that our ability to estimate demand is not going to be as accurate. All right, so I'm now going to add in this third point, or this third set of data points. And now you see our R squared is 0.85. So it is not doing such a great job of really estimating what actually occurred. So at $2, we're estimating 1,100, or I'm sorry, 1,107 units sold at $2, and in fact we only had $913 worth sold. And if we were to put $1.90 in here, we would see that we should be at, we're estimating we're at 1,371, and we actually had 1,500. So we're getting further and further away from what actually occurred, which means as we use this to estimate our demand and in fact come up with our maximum profit based off of our optimum price, this is going to be a little bit further off. All right, so since this R squared is below 0.84, and it's up to you to determine what is not appropriate for you to use. Some people might say that anything above 0.75 is good. Some people may go down to 0.5. I typically say that a 0.9 or above is good. If you're below a 0.9, you should consider trying to come up with a different estimate. And that's what we're going to do here. So instead of using a linear equation to explain this, we can see that what's happening is there seems to be some curvature now going on in our demand curve. All right. So instead of using this line, I'm going to actually delete this trend line, and I'm going to instead go in, right mouse click, add trend line, And you could see we have some other trend line options: exponential, logarithmic, polynomial, power, and moving average. And what we're going to use is a power. You could use an exponential or a logarithm, but in this case, a power might work just fine. And typically, this is the next place we would move in terms of trying to figure out an appropriate trend line, especially if we're moving away from something that seems to be linear. All right, so I'm going to add a power in here. I'm going to still do my equation and display my r squared. With some of these other trend lines, it will not give you the ability to do an equation or do an r squared. You do have that capability with sorry, with the power. Okay, and we can see that our r squared has gone back up to something that is a little bit more robust than previously using the linear equation. And we see that we have a line that is curving, and it seems to be curving along what we would find in terms of our data. All right. Really quickly, I'm going to explain this just a little bit. I'm not going to spend too much time trying to explain this power. Let's change the size really quickly. All right. So if you remember with the linear equation we used before, it was the slope times the price plus the intercept. Well, in this one, now we have a power. So what we have is something that is a slope times the price, and then we have this exponential. And if you know anything about exponentials, especially negative exponentials, as you move closer and closer to zero, then what happens is that this becomes 1. All right. As this becomes 1, then whatever you have here becomes whatever is your base. Okay. So we have a base, multiply that times our price, and then we move, we reduce that by this exponential function. All right. And the exponential function, really what it does is the further or the larger your price gets, so the further out we get on the price point, the more this is going to flatten out. All right. So the less this price actually has any kind of impact on this. Again, it's moving towards 1. So that means price will not really have any kind of impact on I'm sorry, this moves towards 0. And that means this will have, or 1, 1, 1. This will have smaller and smaller impact on our our demand. Okay, I may not have explained that right. I might have to go back and re-explain that. But anyway, you get the gist. And so here in the demand, we're going to actually put in this equation instead of our previous linear equation. So now we're not going to use this intercept and this slope. And unfortunately, there's no way that I am aware of. Somebody else might know of a way that we can calculate this power intercept. And really there's no intercept, but kind of this base and this slope function here. Using different formulas, but I don't know how to do that. All right, so going back here, what we're going to do is put in 46743 times the price, which in this case is $1.90 for now, and then we're going to do a caret, which gives us our power. and we're going to raise this to negative 5.49. Hit enter, and now we see that we have something relatively close to what we were expecting at $1.90. If we put $2 in here, still a little bit off here. Let's put 220 in here and see. But we see this one is coming a little bit closer. So again, we don't expect this to be completely right on the money, because we know that our square, our explanatory power is not a perfect explanation of what we would expect, but this does a much better job in our demand curve of explaining the data we have. So this just lets you know that the more data points you have, the more likely you can see if your demand estimate is something that's accurate. If we only had these two price points without this third one, we might not necessarily see that this curve occurs. If we only had these two price points, we might do a linear equation that goes straight down this way, and that's not accurate in terms of this data. Or if we had the second two price points, then we might see a linear equation that just is kind of flat this way. So that's the benefit of three price points. You may not always be able to get multiple price points of three or more, and that just takes a lot of effort, and a lot of companies don't have the capability of doing that. But certainly, if you have the data, then this adds more robustness to your ability to do price optimization. Again, now that we have this demand curve that's more accurate, we can go into Solver. I'm not going to do it now, and solve for maximizing our profit by changing our price, and figure out what that would be now that we have this demand curve. So that's it for price optimization. Again, my name is Eric Riney from Webster University. You can contact me at my email information. You can also contact me on Twitter or LinkedIn, and certainly you can find me on YouTube. Join me for another one of my marketing analytics videos. There are more to come, and if you like this one, hit the like button, and you can also join my page. Take care, and I'll see you soon.
Here comes a brand new flavor in your ear. Time for new flavor in your ear. I'm kicking new flavor in your ear. Like a brand new flavor in your ear. Here comes a brand new flavor in your ear.
Yes, it's always time for marketing analytics flavor in your ear.